Good morning, everybody. Nice to see you. So, I owe somebody a big thank you, and I don't know who it is, but I was setting up for basketball yesterday, and I saw our principal, Mr. Silva. Mr. Silva said he was evaluating in a science class yesterday, and one of you whispered over, "Yeah, I have Mr. Stirrup for math. He's awesome. He records all his lessons. We know exactly what we're doing at all times." Thank you, whomever that is. That's awesome. So that made me feel good. Anytime I get, my boss saying, "Hey, that's what a kid said about you." Sometimes it's, "Hey, this kid said this about you." Going, "Oh, geez." But that was like awesome. So thank you. That made my day. I've seen. I wasn't on the computer a lot last night, but I have seen that quite a few of you have actually gotten into the Schoology to finish up tests or redo tests and things like that. So good job for all of you. I have the windows set up until for all of those, and then I actually put another one in there now. They will all be due Friday of next week. So they're just a couple questions. TJ said he had problems getting into one. Does anyone else have any problems? Which one? Three. Is that the same one?
Yeah, 2 and 3.
2 and 3? Okay. 3. 2 and 3. I'll take a look at those if you haven't gone. I'll take a look after this class period to figure out what the holdup might be. As far as the Schoology, I don't think it's anything you guys are doing wrong because you're doing other quizzes. So I might not have clicked a certain button I should have clicked. Other things, let's see. We are now solving quadratics, and solving of the quadratics comes down to you're determining what the solution to the problem would be. I forgot to say this, but I think some of you might have known this, but if you solve a quadratic, so if you've come down and you found that like x is equal to 3 and x is equal to 6, what that means is if you were to take 3 and 6 and plug it back into the original, the answer would come out to be 0. Okay? And then I'd also briefly spoke that if you had drawn a number line and labeled it x, you would be able to put solid dots on each of those. And what we're leading to is things that are raised to the second power are parabolas when you graph them. Okay? It's not a straight line, it's a parabola. It's a line that you have a vertex, a high point, or a low point, and you have solutions that could be. And there are sometimes that the solution might be something that doesn't make sense right now, but it would be a solution. I'm not saying like you get an answer of smiley face. You would get an answer that might come out to the square root of a negative number, and that doesn't always comprehend, but that falls into a number system called the complex number systems, which deals with square roots being negative. So I wanted you guys to work on 11 through 18 yesterday. How did that go? Pretty solid. Feeling okay about it? Yeah. Okay. So the main difference between these as of right now is they are equal to 0. There's an equal sign and equal to 0 for the most part. Agree? And so what I want to do is I want to run through the homework a little bit and just see how that went for you. I have the problems written up on the board, which I know they're hard to see now that there's a glare on that board over there, and it's written in red, which, it is what it is. Sorry. But I want to look at numbers 11 or 12. One of those that you'd like to see, just 11 or 12. 11? 11 okay? Okay. Problem number 11. Okay. Item 1. What stands out that we are going to solve this and not just break it down into 2 binomials? What stands out right now? What about 0? it's equal to 0. God bless you. So I want you to start realizing that if it stands alone, it breaks down into binomials or greatest common factor in binomials or greatest common factor and whatever else. If it says an equal sign in it, and the main thing is really the equal sign means you're solving it if you have an equal sign, meaning you're trying to figure out what you could plug in for the letter that would make the whole thing equal to 0. If there's an equal sign, you're solving it. If there's not an equal sign, that means you're breaking it into two binomials, a greatest common factor of binomials, a greatest common factor, and something that can be factored out. The ones that we used to call prime that we couldn't factor out actually do indeed have a solution. It's just we haven't learned how to find that solution yet. So we will get there. So on this particular problem, I don't have a greatest common factor. I do normal like I always do it. I'll just look here. I don't have a greatest common factor. I do know that I have to multiply for my thought about number, my dream number. My dream number is 35. My dream number is positive 35 because of this being positive. And that tells me both of my signs either have to be positive or negative. What do you think? They're both positive because this points to both being positive. And I'm just going to list the factors of 35. 1 and 35 and 5 and 7. Of those factors, both being positive, if I were to sum two of them together, 1 and 35 would give me 36. And 5 and 7 would give me 12. So which two am I going to use? 5 and 7. So these are going to work. These are both positive. So again, we're going to take this first term. I have x squared. Take my last term. I have 35. And I'm going to go plus 5x plus 7x. Okay, and again, those two have to sum together to give me my original. Greatest common factor there, x, that leaves me x plus 5, plus greatest common factor here, 7, that leaves me x plus 5 as well. Break this down to this and this, so I get x plus 5 and x plus 7. So we have factored it, but this wants us to solve it. What says to solve? Equals 0. It's more of just the equal sign to solve. So I'm going to take each of these and set each of these equal to 0. So I'll drop the parentheses and solve it. So when it's just a single numeric value, it's pretty easy to solve it. It's just the opposite sign. And a lot of kids are like, oh, I just want to do opposite sign, and I'll be done. And you're right, and this one will be subtract 7 from both sides. If I were to take negative 5 or negative 7 and plug it into x squared plus 12x plus 35, the answer would come out to be 0. Okay, and again, these two answers do indeed wind up on a number line. If I drew a number line and I had 0 here, and I had negative 5 here, and I had negative 7 here, these are the two spots that they would be located. Okay, and again, that number line part is just understanding where it falls on the number line. We're not requiring you to put it on the number line yet. This is just something that we're going to see eventually. So this is what your answers are going to be. Is that okay? Can I clear? All right, now I want to look at 13 and 14. Either of those you'd like me to take a look at? 14? Okay. Number 14. We are solving this. Why? How do we know? Equal sign. So I have to factor it, and then what my factors are, then I'll set those equal to 0 and solve it because of the equal sign. So we're going to go through the same process. Do we have a greatest common factor that these all have? Yeah. So I'm going to factor 3 out. That's going to leave me x squared plus 3x minus 40. Is that okay? Now I want to do a little side note for a second. Just a little side note. I have 3 times this whole quantity. Do you agree? 3 times this whole quantity. So technically this 3 could come down here and we're going to do this. Do you agree? That's what we had been working on. But technically, let's say I had this as a problem. 3x equals 0. How would I solve 4x. Divide everything by 3. So if I did this, I'm going to find that x is equal to 0. Yeah? So this whole quantity is acting just like x would be. So what do you feel I could do from here to mimic what's the property going on here? What would I have to do to both sides? Divide by 3. If I divide both sides by 3, watch what happens. Okay? So do I need this 3 here? No, I'm solving it. If I just needed a factor and want to know what this breaks down to in its components, it's going to have this. But being I have a 3 out front, a greatest common factor out front, which is a number, I can just divide it on both sides because I'm trying to solve it. And once I solve it, I'm going to figure out what I can plug into the x's in the original problem, and the answer will come out to be 0. But this 3 right now, because it's the greatest common factor, technically I could divide both sides by the 3 and get rid of it. Okay? You are totally allowed to continue it down here because what's going to happen is you're going to get 3 equals 0. Well, that's goofy. And then this equals 0 and this equals 0, which is going to get you some solutions. Okay. Magic number is what? Negative 40. In order for me to multiply two numbers together and the answer be negative, what do you know? Negative times negative is positive, though. They have to be alternating, right? So positive, negative, or negative, positive? Okay. And now I'm going to go 1 times 40, 2 times 20, 4 times 10. How much? 5 times 8. Anything else? Okay. So they're going to, one has to be positive, one has to be negative, yes? So let's go ahead and start this. I'm going to do x squared, and then I'm going to do minus 40. Which of those, one being positive, one being negative, would add up to give us positive 3? There you go. Positive 8 and negative 5. Is 8x minus 5x 3x? Yes. Uh-huh. So that's going to work for us nicely. What do I have in common here? So then I have x plus 8. If this is negative, what do we know? Negative is going to be on the outside. So negative 5 comes out of both. That's going to leave me x, and that's going to change that sign because I factored negative. So what are the things down below? X minus 5 and x plus 8. Good job going backwards, but you got it. Okay? So again, you remember this 3 in the beginning where we said, hey, if we divide both sides by 3, it's gone? So this is my factored form, but I don't really need that 3. But what I can do now is then say, well, x minus 5 equals 0, and x plus 8 equals 0. So x is equal to what on this first one? 5. And 8, or x is equal to what on this next one? Negative 8. So again, that's our answer as far as we go. If we were to make a number line and call it our x number line, we would put a dot at positive 5, and we'd also put a dot at negative 8, and those would be the solutions. If I were to take 5 and plug it into this original equation here, my answer result would be 0. If I were to take negative 8 and plug it into my original problem. What I mean by that is I'd go 3 times 5 squared. 5 squared is 25. 3 times that is 75. Plus 9 times 5, which is 45. 75 and 45 added together is negative, or 120. 120 minus 120 is 0. Same thing with the negative 8. If I have to take negative 8 and plug it in, negative 8 squared is positive 64. Positive 64 times 3 is 192, I believe. And then 192 minus 72, because 9 times negative 8 is negative 72, gives us 120. 120 minus 120 is 0. That's what I mean by the solution. Okay? So, kind of a lot of information that these problems have. We're going to start getting into what happens when we graph these. Now here's here's something just for you to think about. Okay, and I'm not saying that you all are going to do this, but gravity, if I take this pencil and drop it, or pen and drop it, it's accelerating towards the floor or towards an object in which it will interact and stop, and it will release its energy into whatever that object is, correct? Yeah. A little physics there. So a free-falling object, though it does have something called a terminal velocity, which is a buoyancy factor, meaning it's the pressure of the gases that are keeping it buoyant, will have you slow. But originally when you start to drop in something that is a quadratic function. And you fall at a rate at negative 9.8 meters per second squared, which means that for every second you fall, you accelerate yourself another 9.8 meters per second towards Earth. And that, of course, changes the different planets you go on, but as far as Earth goes, and a lot of times in your science classes, they'll say, well, let's call it negative 10 meters per second squared because it's close, but it's not exact. But the thing is, an object will continue to accelerate faster and faster and faster and faster. It goes along with an equation which is called 1/2 dt squared, where d is the distance, t is the time. And you can figure out how fast an object is falling from a certain height. You guys ever hear the thing, if you were to take a gun, and I'm not saying bring a gun to school by any means, if you were to take a gun, hold it parallel to the floor, and you were to shoot the gun, and you take a bullet, the same bullet that would come out of that gun, you drop the bullet at the same time you shoot the gun. Do you know this bullet that you drop from your hand to the floor that was equal with where the gun was, and the bullet that comes flying out of the gun, they will strike the ground at the same time? And why does that work? Because the only force, once the bullet has been released from the casing, is the force of gravity straight down. So, again, that all has to do with this type of problem. Now, does everything x squared have to do with gravity? No. It's just one type of thing to think about. Okay? I love that show, Mythbusters. Are they still making new ones?
This is their last season.
Is it really? They got some cool stuff on it. I think what a cool show. You know, you're bringing science into, you know, the prime time of life, and they have the entertaining factor to it. Let a lot of people watch it, which I think is great. Number 15 or number 16? Which one of those would you like to see? Number 15 or number 16? 16? 16, let's do it. Can I clear this?
Yes.
Number 16. I have x to the third plus 19x squared plus 60x equals 0. Okay, we know we're solving it because of what reason? There's an equal sign. Okay? The equal sign says, hey, let's solve it. Okay, so we'll have to factor it first. I think I'll have the greatest common factor on this one. What do you think the greatest common factor will be? X? Okay. Did we have a greatest common factor on the last problem? And what was the greatest common factor on the last problem? I forget.
3.
A 3. So the first problem we did, we had a greatest common factor that happened to be 3. This is going to have a greatest common factor, which is going to be x. Okay? What's the difference between a 3 and an x? One's a letter. What's a letter called in math? Variable. A variable can change, correct?
Yes.
Okay? A number is a number. It doesn't change. So, on this particular problem, you are completely allowed to say, hey, let's bring this x down, and let's factor it. But what's going to happen here is, do you think x can equal 0? Is that something that x could equal? Because x is a variable can represent any number, so could x equal 0?
Yes.
So what do you think one of my solutions to this problem would be? Equals 0. So this problem has a solution of x equals 0 as one of its solutions. Are you okay with that? Now let's think about this. If I were to take 0 and plug it back into the original blue problem, what is 0 to the third power? Which is 0 times 0 times 0. That's 0. Okay, and then I have 19 times 0 squared. Well, 0 squared would be 0. 0 times 19 would be 0. Okay, and then 60 times 0 is?
60.
60 times 0 is 0, but close. Okay, so that would mean that I get 0 plus 0 plus 0 equals 0. True or false? True. Nothing plus nothing plus nothing equals nothing. Not like the federal government going, hey, we have nothing here left, but we're now going to spend here. And you're like, where'd that come from? So, one of my solutions. This is one solution of it. Okay? So, have I taken care of this solution here? If I say x equals 0, have I taken care of that solution for that I just underlined? Yes. So let's not worry about this. So technically that's done there. This has been taken care of right there. You following my arrows? So now what I need to do is I'm going to take x squared plus 19x plus 60. Okay, I'm going to factor it. So what's my magic number? What's my magic number? 60, positive or negative? Positive. In order to get a positive, I multiply 2 positives and 2 negatives. Which is it? 2 positives. How do you know? Addition sign right here. Good. All right. So I know that I'm going to take the factors of 60. So I got 1 and 60. I got 2 and 30. I have 3 and 20. And I have 4 and 15. And I have 5 and 12. I have 6 and 10. I think those are all the factors. I think. Are there one of those that are going to add up to what number? 19. What do you think it is?
4 and 15.
4 and 15. I love it. 4 and 15 right there. They're both going to be positive, yes?
Yes.
So I have this x squared here. I have this 60 here. Okay? I'm going to go plus 4x plus what? 15x. Look to these two. What's my factor? X. What do I have left? X plus 4. What do I have here as a factor? Plus 15. Excellent. X plus 4. Okay. What's this answer? What's going to fill in down here?
X plus 15
X plus 15 and X plus 4. Good. So, I'm going to set each of these equal to 0, yes? So x plus 15 equals 0. So what's x equal there? Negative 15. X plus 4 equals 0. So what's x equal here? Negative 4. How many solutions does this problem appear to have? 3. Let me say that one more time, everybody. How many solutions does it appear this problem has? 3. What was this problem raised to originally? The third. Now, the last problem we did that also had a greatest common factor, which was a number, was raised to the second power. How many solutions did that one have? 2. Well, a lot of these problems that have been raised to the second power, we've been having how many solutions? 2. So if you have something raised to the second power, you have 2 solutions. You have something raised to the third power, it appears we have 3 solutions. So I just want to think about this, but do you think it's possible that something raised to the 4th power could have 4 solutions? Or something raised to the 20th power could have 20 solutions? Or something raised to the 6,000 power could have 6,000 solutions? Yeah, now I don't think we're going to hit a 6,000 power problem. But what I just talked about just now is something called the fundamental theorem of algebra. Whatever the highest exponent of your problem will indicate the number of solutions you have. Do you think it's possible that I have a solution that is the same thing repeating? Like, we had worked a problem one time, and I think it was Ray that asked about this. He said, when we factored down, we got like x minus 7 and x minus 7, which would yield us an answer of x equals 7 and x equals 7. but it was still squared. And actually, x minus 7 and x minus 7, if you put it back together, that came from the problem of x squared minus 14x plus 49. If you factor that, you get x minus 7, x minus 7. So it's possible your solutions can be the same thing. Okay? Which leads us to something when we start dealing with parabolas of, does our vertex, or does our parabola come down and touch our x-axis once, or does it go through it twice? Okay, and there are times that it won't ever go through it. And if it doesn't go through it, that means they have complex solutions, which means those solutions are going to be strange because we're going to get the square root of a negative number for a solution, which stands for a complex thing. And that's, 5 weeks from now, but I just wanted to put that out there. So, again, we're trying to get to parabolas. We just talked that gravity has to do with parabolas. Okay, it's the same kind of mathematical operation. And then we just came across a problem that originally it was find a factor, but now it was raised to the third power, and we came up with 3 solutions. That means if I were to take those 3 solutions, plug it back into the original blue problem, I would then get 0 for an answer. Ray, question? No? Okay. I think I'm getting a little better at this stuff. Okay? I've gotten to a point, and I've put out there that there are more to it than just what we see here. We are going to get to a point where we're going to start graphing these by hand, and I don't want you to fear it. Because if you're graphing something, you're drawing. And I've seen some of your guys' notes in your tests and stuff. A lot of you like to sketch a little picture. It helps you think. So then I'm going to sucker you into drawing a picture, which you're already doing, and now we're going to apply it to math. I'm sorry. I didn't mean to do that to you. You're like, man, dang it. Drawing was great. It's out of the picture now. This guy ain't going to get me to do math. He's crazy. He's speaking crazy tongue up there. All right. Let's. I got a sheet I made up. It's kind of generic, but it's going to help us along with some notes. It's your choice if you want to choose to do notes on this, or if you want to do it on your own, or if you always want to sit there and stare at me, which is also fine. Just as long as you're absorbing something. Okay. We have a little warm-up. Just a little warm-up. Going to the cards. Here we go. Who's up first? We'll never know. TJ, your name was on top. You know what that means? You're going to the back. Stevie, you're up. You ready? So we're taking a look at this first problem. This is review. Stevie, I'm going to tell you that x squared minus 49 does fall into the category of difference of 2 squares. The reason I know that is because x times x is x squared, so x squared is a perfect square. And 49 is the same thing as 7 times 7, which makes 49 a perfect square. If it's the difference of 2 squares, we are separating them by a subtraction sign. Okay? Now, you're totally allowed to ask Ray if you need to, but do you know what x squared minus 49 would factor down to? What do you say? X plus 7, x minus 7. X plus 7 and x minus 7. Okay, so difference of 2 squares works this way. If I were to multiply this back together, I would get negative 7x, positive 7x. That would cancel out the middle term. Okay? But the reason this works is I look at the square root of this, I look at the square root of this, I put the square root, the square root, the square root, the square root, alternating signs. Question, Preston. This was called the difference of two squares. Is there something called the sum of two squares?
Yes.
There is, but can they be factored? No. Sum of two squares doesn't factor. Difference of two squares does factor. Okay? All right. Hey, what would happen? What do you think would happen if we did this? So is the red right then?
Yes.
What would I do with the red from there?
Do that equal to 0.
Yeah, I'd set each of these equal to 0, and I would find that my answer is -7 and 7. So if I were to make a number line, I would put a dot at 7. I would put another dot at -7. So the difference of two squares has how many solutions? 2. Okay? Boom. 9x squared minus 25 is indeed the difference of two squares. The reason I know that is because 9x squared is the same thing as 3x times 3x, and 25 is also a perfect square because that is 5 times 5. So with that kind of information, you know what this would factor down to? Both. Almost. 3x plus 5 and 3x. It's going to look the same. So I'm going to get 3x plus 5 and 3x minus 5. This was raised to the second power, yes? How many solutions should it have then? 2. So if I were to solve each of these, I'd set each of these equal to 0. Still with me? So on this one, I would subtract 5 from both sides, and then do what? 5? 3. There's one answer. What do I do on this one? I add 5, and then what? Divide by 3. I have -5/3, which is the same thing as -1 2/3, and I have 5/3, which is 1 2/3. Is -1 2/3 and 1 2/3 on the number line? Yeah, those are solutions to the problem. Cool. Garvey. Yeah, baby. All right, this one right here. Doesn't appear to be difference of two squares right off the bat. It might be, I don't know. I have two terms, there's a subtraction sign, so I'm thinking it might be difference of two squares somehow, but I might have a greatest common factor originally. What can I factor out of both of those? X and 5. If I factor a 5x out of 5x to the third, what do I have left? To the second. So 1x to the second, which is x squared, minus, if I factor a 5 out of 125, 25, if I factor an x out of x, that's gone. What does this look like right here? What does that look like? Preston. Difference of two squares. So I have 5x. Preston, what does that factor down to?
That will factor down x plus 5 and x minus 5.
X plus 5 and x minus 5. All right. If I had solved this equal to 0, that means I'd go 5x equals 0, x plus 5 equals 0, x minus 5 equals 0. Yes? So what is this answer here? 5x equals 0. What's 0 or x equal to? 0. 5 plus x, so what's x equal to? -5. 5 minus x, what's x equal to? How many solutions does that appear? 3. What was our original exponent we were raised to? To the third power. Does that follow along with that fundamental theorem of algebra I kind of indicated that might be pointing to? It's raised to the third power. I have 3 solutions. Those solutions, if I take any of those 3 solutions, plug back into the original, I should get an answer of 0. If I don't, mathematically it is something incorrect. Okay. Are we okay? Life good? No? All right. What's the next thing it says on there?
So when you factor in the 2 by 0
Okay. So let's answer that question. Georgie, When do you think we will solve a problem? What sticks out to say, solve me? Equal sign. When do you think I'm going to factor? What am I missing? What am I missing if I'm just going to factor it? What is the problem not going to have? An equal sign. Okay? I have an equal sign. We need to solve it. Let's factor it, break it into binomials, break it into greatest common factor binomials. Let's solve it. There's an equal sign. There's not an equal sign. That points to, hey, just break this down into better components. The components that we'll break it down to could be binomials. It could be a greatest common factor in the whole problem. It could be a whole lot of things. So, all right? Okay. All right, so let's talk about this. If we had, let's say we had, let's say we knew the area of a rectangle goes along with this. Let's say we have the area of a rectangle is equal to that. Still with me? Okay, so some things that I know. I know a rectangle looks something like that. We have 4 right angles. We have 2 sides that are parallel to 2 other sides. And 2 sides on opposite sides are equal to each other, and top and bottom are equal. So the left and right are equal, top and bottom are equal too. We have been forced to think that length times width is how you find the area of a rectangle. And they've told us in elementary school that the length is always longer than the width because your elementary school teacher didn't really have a clue on the concept. But it is what it is, but we love them anyhow, right? Yeah. Elementary school was good. Remember what silent, or not silent reading? I always thought silent reading was okay, but you know what was better? Nap time was good, but what was better than silent reading though? Snack time was good. No, I loved it when the teacher would like read us a story. I love that. Like, okay, everyone, come on, gather around. I'm going to read you a story. And you'd be sitting on the floor, you're like, yeah. And you sit there and make pictures in your mind of what the story was. I thought that was cool. I thought that was cool. You know what? Real quick, I had done this a few years back. So I've told you guys that I taught at Reno. And when I was at Reno, Nevada, it was an inner city school. We had a lot of gang kids. We had a lot of kids that were in gangs. We truly had 2 major gangs in our school.
Oh, what do they call it? Like the Sharks and the Jets?
No. We had Sunset and Southside. And Sunset was related to MGR, Montevideo. And,
okay, so wait, Sunset and what? Sunrise?
Southside.
Oh, okay.
So, and these gangs, they were bad. These gangs, they stem back to the Bloods and the Crips. They stem back from, they had some deep roots. And I had a lot of kids that, so the state of Nevada, as good as the place seems to be, is not this mecca of education. Like, education is not something that they go and pour their money into. They pour their money into, hey, let's build another casino and people will come and see it. They don't really have, but the state of Nevada, in their infinite wisdom, decided the best idea for kids in high school is the lowest math class that we will ever teach will be Algebra 1, which is this class. And I remember when the school board was proposing this, and this came down from the governor, and I went to the school board meeting, I said, I need you to understand something. I have kids that are 14, 15, 16 that are coming to my math classroom. They have never had formal education ever because their parents came from a country south of here, and they didn't have formal education from where they came from, and their parents found that there was a job in Fallon working in the fields. And I said, what's your point? And I said, well, you're telling me I have to teach kids Algebra 1, but these kids can't even write numbers. Why can't they write numbers? Because they never went to school. Why do they go to school? I just told you. So I'd be chasing a dog around a tree, trying to tell the school board, who are elected officials by the eminent bright people of society, who are going to run our school districts, and it was fantastic. But they would sit there and say, no, it's your job to teach these kids Algebra 1. And then I'd be like, okay, I understand that. Could I have 4 or 5 years to do it? Why do you need that? Because I have to backfill their education, because they don't have an education that came from a formal education system in the United States, because they came from a country that didn't have formal education in a lot of parts, and their families felt they'd make a better living for themselves coming here. Like, we don't get it. I'm like, oh my gosh, you guys are dumb. And it was horrible. So, anyhow, I'm sitting there with, 25 kids. They want, just like you, figure out life. What can I do for the rest of my life? Right? Okay? What's going to make me happy? What's going to make my parents proud of me? What's going to make me happy? What can I do? What should I do? Things like that. So, our school decided, okay, in order to try and fill this problem, we will have kids take Algebra 1, and if they're in Algebra 1, we will identify these kids that didn't have anything good background in math, and we will have them take a math support class along with Algebra 1. So you already are not good at math. Now you're going to be stuck in 2 periods of it, one that's a support system of the one that you're going to have. So I had a 4th period class, and then we had lunch, and then I had a 6th period support class. Same exact kids. At least they had lunch in between me, right? So I would go and teach them algebra during 4th period. They would all go to lunch going, dude, I have no idea what happened. And then they would come to me 6th period, and I would be trying to say, okay, so we talked about this problem has some fractions. Let's talk about fractions. We show how to add, subtract, multiply, and divide. Well, I started realizing that these kids, though they came from caring, loving parents, they didn't have a lot of things that other kids might have. These kids did not have the development of an imagination because they were not involved with things being read to them. And so I decided, you know what? Guys, you're in 6th period. For the first 15 minutes of class, I will read you a book. And it'll take us a few weeks, maybe a month and a half, to read a book. I said, I just want you. So the thing is, I had these kids in gangs, rival gangs, same class. They wanted to stab each other in the neck. You're treading on my turf. No. Yeah, we had some bad stuff. First book I read them. No, The Outsiders.
Oh,
You know what this did with these kids? I want you to think about this. These kids, one, they were told they had to go to school. They get to school, and it's like they're getting hit in the face every day going, I have no idea, because they didn't have the background of education to come up to that point. But yet they're 15, 16 years old, sitting in my class, and they'd never been in school before until that point in time. I get to high school. So I started reading The Outsiders. The Outsiders was a pretty good book to read. And you know what they identified with? They loved, dude, you got a guy named Pony Boy? You got all these cool names. And you know what I do? I started noticing that the tardies after lunch decreased dramatically because I was doing something that these kids bought into and they loved. And they thought this was fantastic. And you know what I did by doing that having these kids for 2 years in a row? Is I was able to develop an imagination on these kids that developmentally never took place because they were not in a system that allowed for this type of thing to take place. And you want to talk, beautiful things to watch. You watch these kids that they had hope. And that's one of the things that I saw with these kids. It was wonderful. And I still think of those kids to this day because there were some of them, broke your heart. They'd go get jumped into a gang. They'd come to class collarbones broken, face all mangled. What happened? 6 guys beat me up for 4 minutes. Why? Well, mister, I got beat up every day going home from school, but now I won't get beat up ever again by those guys. And I'm thinking, shoot, we're over in the Middle East fighting terrorism? I got a 15-year-old kid that's terrorized to walk from school to home or home to school. So, this type of problem is something that we will focus a little bit more on. Guys and girls, I would like us for next time, these are very similar problems to what we've been working on, but I would like you to work on worksheet 11A, which is page 25, and let's have you guys work on 1, 4, 7, 10, and on the back side 13 and 16, which is the left column. Guys and girls, if you need to take a picture of this, it's the front and the back side, so make sure you take a picture of both sides. Reese, don't take it. It's not yours.